Hello friends, welcome to CareerClust Learning. Today we are going to discuss about most important and powerful concept, that is cloud computing. Cloud computing is very important topic. If you are new to our channel, don't forget to subscribe to our channel. Please share your thoughts by commenting. If you are looking for a job, we have very good collection of jobs in our application, that is careerclust.com. Please open that in browser and add it as a PWA on your mobile. Let's get started. What is cloud computing? Cloud computing is the delivery of computing services such as servers, storage, databases, networking, software, and analytics and AI over the internet. That is called as cloud, instead of using your own physical infrastructure. The simple definition of cloud computing is cloud computing allows you to rent IT resources on demand from cloud providers rather than buying and maintaining your own hardware. Think of it as like electricity. You don't build your own power plant. You use electricity when needed and pay only for what you consume. Cloud computing works in the same way. In simple words, on-demand delivery of computing resources over the internet, like servers, storage, databases, networking, and more. What we can achieve with this cloud computing? Scalability, cost efficiency, global reach, reliability, speed, and flexibility. Instead of buying and maintaining physical servers, you rent computing powers from a cloud provider and pay only for what you use. This is a simple definition of cloud computing. Cloud service models. There are basically three kinds of models we have in cloud services: IaaS, PaaS, and SaaS. Infrastructure as a service, platform as a service, and software as a service. What you manage versus what the provider manages. This is the main difference. So, if you think about IaaS, that is infrastructure as a service, you manage applications, data, runtime, middleware, OS. So, in infrastructure of service, the provider provides virtual servers, storage, and network. So the provider manages virtualization, servers, storage, networking, and you manage application, data, runtime, and middleware OS. Some examples are AWS EC2, Azure virtual machines, GPT computing machines. Here you manage applications, operating systems, and runtime, and provider manages hardware, networking, and data centers. And PaaS, that is platform as a service. So in platform as a service, provides a platform to build and deploy applications. So in platform as a service, you have to manage applications and data, and provider manages runtime, middleware, operating system, virtualization, servers, storage, and networking. So some examples are like Azure App Services, AWS Elastic Beanstalk, Google App Engine, Heroku. These are few examples of PaaS, that is platform as a service. And the other type of infrastructure is, other type of provider is SaaS, that is software as a service. In software as a service, it is ready to use software delivered via internet. So here you manage, as a user you manage, just use the app, like, and provider manage everything else. So like some examples are Gmail, what you are using, some Salesforce, Microsoft 365, Zoom, Slack. So here no infrastructure management required. So everything is provided by the service provider, and just you need to use that one. So we have three service models: infrastructure as a service, platform as a service, and software as a service. And deployment models. So there are three kinds of deployment models basically. So where and how your cloud infrastructure is hosted. So here we have public cloud. In public cloud, this is shared infrastructure managed by provider, accessible over the internet. So it is provided with very low cost and no maintenance, and it is scalable. And when to use? It is startups, variable workloads, and cost-sensitive projects. Some examples are AWS, Azure, and Google Cloud. These are most common examples. It means shared infrastructure provided by the cloud vendors. And another deployment model is private cloud. In private cloud, it is dedicated infrastructure for a single organization or on-premises or hosted. So what we can achieve with it? It is a full control, security, and compliance. And when to use? Regulated industries, sensitive data, and strict compliance. Some examples are banking systems and government applications. It is more control and security. And another deployment type is hybrid cloud. In hybrid cloud, it is combination of public and private clouds with the data and apps moving between them. So we can achieve flexibility, cost optimizations, and gradual migrations. When to use? Enterprise with legacy systems migration to cloud. So whenever an enterprise application is going to migrate to cloud, so it is partially on the private and partially on the public. So it is a hybrid cloud. Another type of deployment model of cloud computing is a multi-cloud. A multi-cloud is using services from multiple cloud providers simultaneously. So what we can achieve with multi-cloud? No lock-in, redundancy, and best services. So when to use? Avoiding vendor lock-in, best for breed services. So these are some deployment models of cloud computing, that is public cloud, private cloud, hybrid cloud, and multi-cloud. Major cloud providers in the market. So there are big three dominants in the cloud markets. The first one is AWS, Amazon Web Services, that is 32% of stake in the market. And next is Azure. So Azure is it is provided by Microsoft. It is having 23% of market share. And next is GCP. It is provided by the Google Cloud provider. The market share is 11%, and others is of 34%. So there are some others are some vendors like Cloudflare and all. AWS, Azure, GCP are major cloud providers. And in AWS we have 32%, right? So few examples are EC2, that is virtual servers, S3 for object storage, Lambda for serverless functions, and RDS for managed databases. And among the 23% of Microsoft Azure, we have virtual machines for computing power, and blob storage for object storage, functions for serverless computing, and SQL database, that is managed database. And GCP we have 11% of market share. It is compute engine called as virtual machines, and cloud storage we use object storage. Cloud functions, this is for serverless, and BigQuery for data analytics. So these are major cloud providers in the market. AWS, that is Amazon Web Services, the provider is Amazon. Azure is 23%, it is provided by the Microsoft. and GCP of 11%. It is provided by the Google. What is serverless computing? So in serverless computing, it is event driven, pay for execution, and no servers to manage. That is simply a cloud. So here the characteristics of serverless computing are pay for execution. So only pay when your code runs, not for idle time. So it is like renting the services whenever we are using it, not for the time when it is idle time, or when it is sitting idle. That is pay for execution. And auto scaling scales from 0 to thousands of requests automatically. So it is like an application will be having some peak hours and non-peak hours, and some applications will get very huge demand during some festival seasons or some its specific occasions. So there is no need of paying high charges to the non-peak hour during the non-peak hours. So in the cloud computing, it will scale from zero to thousands of requests automatically. That is scaling the application. That is auto scaling. We have two kinds of scaling here: horizontal scaling and vertical scaling. Vertical scaling means increasing the power of a single machine. Horizontal scaling means increasing the machines to distribute the load. So we have a separate video for that. And no server management. As a user, there is no need of managing any servers. So no patching, provisioning, or capacity planning. So it is automatically taken care by cloud provider. And fast deployment. So the deployment is a critical part of our software development lifecycle, and it will have very fast with CI/CD pipelines. Like deploy functions in seconds, it will not take hours. And some limitations of cloud computing: cold starts and can add latency, that is nearly 100 milliseconds to 1 second pace. So cold start is a problem, and that can add some latency to some service calls. And execution time limits to 15 minutes max on AWS. This is another limitation. Limited local state between invocations. So this is another challenge or limitation. Vendor lock-in concerns. And some use cases are event processing, API backends, data pipelines, chatbots, image processing, and scheduled tasks. So in AWS Lambda, Azure Functions, Google Cloud Functions, Cloudflare Workers. So these are some functions we use serverless computing. And cloud security. So this is very important terminology, very important concept to give security to the data or application when we host in the cloud. So it is shared responsibility model, security of the cloud versus in the cloud. So it is what is the customer responsibility in the cloud security? So customer responsibility includes data encryptions, IAM and access control, OS patching, that is IaaS, application security, and network config. These are responsibility of a customer. And what are the provider responsibilities? So in the provider responsibility, physical security, hardware maintenance, network infrastructure, hypervisor, and global infrastructure. So these are security levels provided by the provider, that is cloud provider. And some security layers are IAM, this is identity access management. Who can do that one? So without a proper approval, proper access, the user cannot log into the system. This is identity and access management feature. And encryption. In encryption, the data at rest, that is AES 256 algorithm, and in the transit, TLS. And VCP is virtual private cloud network isolation. And another one is compliance. So SOC2 or HIPAA, GDPR or PCI DSS certifications. So these are required to access that application outside of the cloud. And monitoring is another very important feature. So cloud trails, security hub, and threat detections. And firewalls, the security groups, NACLs or WS protection. So these are some security cloud security features, and responsibility of customer, responsibility of provider, and the layers like IAM, that is access, identity access management, encryption, virtual private network, compliance, monitoring, and firewalls. Cost management of in cloud computing. So in FinOps, optimizing cloud speed without sacrificing the performance. So the cost, how it is calculated and how the costing works. Pay as you go. So pay only for what you use by the hour or second. So for the non-using resources or for the non-using time, so there is no need to pay for the cloud. So this is called as pay as you go. And reserve instances. So in reserve instances, so 1 to 3 years commitment up for the 72% discount. So it is for discount purpose and reservation of the instances or servers. And spot instances. So if there is any unused capacity at up to 90% discount can be interrupted. And saving plans, so flexible prices with commitment to consistent usage. So these are some cost management techniques and some cost optimization tips in the cloud. So right size instances, so match resources to actual workload, tag everything, track cost by team, project, and environment, schedule non-production, shut down dev or test after hours. Use Cost Explorer, so identify spending trends and anomalies. Delete unused resources, so orphaned EBS or old snapshots can be deleted. Auto scaling, scale down during low traffic periods. So these are some cost optimization tips. So write to size instances, tag everything, schedule non-production, and use Cost Explorer. Delete unused resources and auto scaling down during the non-peak hours. And this is cloud careers. So this is very important one. Cloud computing is high demand, competitive salaries, and clear growth plans. So we have AWS developers or AWS certified developers or architects. So solution architect, associated, and Azure. So Azure fundamentals we have certifications, and GCP, associate GCP engineer, that is also a certification we have. And roles and salary ranges, this is according to the US standards, and it can be also translated to the Indian currencies as well. Cloud engineering around $95K to $150K. Cloud architect, this is more important one, $40K to $200K. And DevOps engineer, this is also very important job, $100K to $165K. And cloud security engineer, $120K to $180K. Site reliability engineer, so it is called as SRE. They play a very crucial role, that is $130K to $190K. Platform engineer, that is $120K to $175. And some learning paths, so it includes networking and Linux basics. It is required networking concepts and Linux basics, Linux commands. Pick a cloud, so you can pick any cloud, and AWS or Azure or GCP. So AWS is recommended for a quick learning, and get foundation certificates. So you can get the foundation certificate on that particular cloud. Build hands-on projects. So merely learning the cloud concepts will not help you much. So you need to do hands-on project on that. Learn IAC, that is Terraform and specialized and advanced concept. Okay, these are some learning paths, and simply what you have learned till now. So some advantages and challenges of cloud computing. Simply, advantages are lower cost, high scalability, better reliability, faster deployment, global availability, improved security, and disaster recovery. These are some advantages of cloud computing, and some challenges are cloud cost can increase if not monitored well. So, vendor lock in, internet dependency, security microconfigurations, and learning curve also one of the challenge. And some takeaways of this entire discussion is cloud computing is the delivery of IT resources over the internet on a pay-as-you-go basis. It enables organizations to build, deploy, scale, and manage applications faster and more efficient without owning physical infrastructures. So, in simple terms, cloud computing equal to on-demand resources plus internet plus pay-as-you-go model plus scalability. I hope you understand what is required for the cloud computing, and this is very important for the interview preparation. Thank you for watching. Please like, share, and subscribe.